Hello everyone. Want to know more about the latest innovation from Juniper Networks in multi-service edge silicon space? Today, I'm going to talk about Trio 6 and all the upcoming MX products which are using this ASIC. Trio 6 is a chipset in 7nm form factor with a total throughput capacity of 1.6 terabits per second. The power budget for this chipset is less than 150 watts, which is approximately 0.09 watts per gig. This makes Trio 6 one of the most power efficient multi-service ASIC capable of supporting all the advanced protocols of today and of the future. It has rich telemetry, sampling, and filter scale, which are capable of supporting advanced DDoS protection mechanisms. The chipset has built-in crypto engine that supports line rate MACsec for all port speeds starting from 10 gig all the way up to 400 gig. It's a true multi-service edge silicon which is capable of supporting all the market use cases such as internet edge, data center edge, peering, mobile backhaul, residential edge, business edge, and infrastructure edge. It has proven scale and performance with many millions of prefixes in fib, unlimited filter and counter or stats scale, high Q scale with edge cost to support all the edge use case requirements, and Trio 6 is capable of supporting millions of prefixes as part of prefix list construct which are needed for many features such as filters, route filters, etc. Trio 6 is built on proven Trio architecture which has been supporting many advanced protocols such as segment routing, SRv6, next-gen replication protocols such as bit index explicit replication. Another important aspect is the unrestricted support of ZR plus optics on all the products which are using this silicon. And to top it all, it operates with industry's most feature-rich operating system, JunoOS. Trio 6 is made up of two slices, each having its own packet forwarding engine or PFE, delivering up to 800 Gbps of throughput. A PFE contains an array of packet processing engines or PPEs. You can also assume them as processors. The PPEs, they form an important construct of the Trio ASIC, responsible for all packet processing functions such as parsing, route lookup, filtering, classification, policing, encap, decap kind of functions. The microcode running on these PPEs, it controls the order in which the packets will get processed inside the PFE. These PPEs, they are independent of each other, so they have full control of the packet and are not limited to a particular sequence of actions. It's built on run to completion model. A packet stays with one of these PPEs until the task is complete or control is explicitly yielded. This run to completion model provides flexibility in the order in which different actions can be performed on a particular packet. So this architecture enables all the functions, making Trio 6 a true multi-service edge silicon. Trio 6 has a combination of on-chip and off-chip memories. It has internal SRAM to implement caches for high bandwidth and low latency accesses to look up data structures and hash tables. It helps in reducing the power budget required for frequent read-write operations which are needed for a packet processing. SBM is used as off-chip memory for delay bandwidth buffer and high scale of floatable record storage. The on-chip and off-chip memories are shared between the two slices. This sharing of processing memory allows for a single copy of the forwarding information base inside the Trio 6 ASIC. This architecture offers a better resource utilization. Trio 6 has 36 SerDes lanes at 56 Gbps towards Fabric and 32 SerDes lanes towards WAN. Each WAN SerDes can run up to 56 Gbps, offering port speeds from 10 Gbps all the way up to 400 Gbps. The ASIC support inline MACsec encryption decryption as per AES GCM GMAC cipher for all port speeds with 128-bit to 256-bit key length. Each slice or packet forwarding engine in Trio 6 has 5 major components. LUSS or lookup subsystem provides packet processing functions. It can be considered as the brain of the packet forwarding engine. It does the job through an array of PPEs or packet processing engines. Internally, each lookup subsystem is divided into multiple quads where each quad can have multiple PPEs. When a packet comes in, then one of these quads perform header modifications. The major functions provided by LUSS through these quads are route lookup, label lookup, firewall, and multi-field packet classification. MQSS or memory and queuing subsystem acts as an interface between WAN and Fabric. It is called as the center chip or the forwarding chip. It has a pre-classifier where packets are categorized as low priority or high priority packets. It provides data path and rich queuing functionality. Unlike initial generations of Trio, where an extended queuing subsystem (XQSS) was used to provide queuing functionality, MQSS on Trio 6 integrates this function. It helps in reducing the overall footprint of the chip and improves the power performance without any compromise on functionality. Memory Control Interface or MCIF acts as an interface to HBM and on-chip FlexMem. LUSS FlexMem is a large cache for processing memory. MQSS FlexMem, it acts as a packet buffer. Now, let's look at the life of packet inside Trio 6. A packet with FCS stripped off is received on the MQSS block either from the WAN or the fabric interface. Pre-classification decides the priority of the packet to make sure that the high priority controlled traffic is protected even when the PFP is oversubscribed. For example, controlled traffic such as ARP is given higher priority over the transit traffic. Now, if the incoming packet is less than 224 byte, the complete packet will be sent to LUSS for further processing. And if the incoming packet is more than 224 bytes, the packet is split into head and tail. A reorder context and a reorder ID is created, then head is sent to LUSS for further processing. The tail of the packet is either sent to on-chip SRAM or MQSS FlexMem or off-chip HBM memory. The incoming packet then gets processed inside one of the PPEs inside the LUSS block. Once LUSS has finished processing, the modified packet with a prepend containing reorder ID, fab ID, scheduler, and queue numbers is sent back to MQSS. Here, reorder entry of the packet is validated, and once it becomes eligible, it is sent to the scheduler. Once the packet based on different parameters such as queue priority, shaping rate, etc. becomes eligible to be sent out of PFE, the content will be read from MQSS FlexMem or HBM, and the packet will be sent out via the WAN or the fabric interface. Here is a quick comparison between Trio 6, 5 and 4. First thing to note is of course the throughput and power. Trio 6 can deliver 3 to 4 times the performance in comparison to previous 2 generations of Trio. That too with much lesser power budget. The reduced power footprint is due to many optimizations done in Trio 6. And one of those optimizations is memory, which directly impacts the DBB size and queue scale. Looking at different POPs where MX has been deployed, queue scale on Trio 6 can meet almost all the use case requirements. It has a delay bandwidth size of 20 milliseconds when all the ports are congested. Please note that in non-congestion scenario, the DBB size will be approximately 100 milliseconds. Trio 6 has more packet processing power because it has more number of PPEs and higher core frequency in comparison to previous generations. Like the previous generations, Trio 6 is capable of supporting HCOS and MACsec at line rate on all port speeds including 400 gig. Now let's look at all the products based on Trio 6 ASIC. First product that I would like to talk about is LC9600, which is orderable now. LC9600 is a 9.6 terabit capacity line card optimized for 400 gig and 100 gig speeds on MX10008 and upcoming MX10004. It has 24 optical slots, which can support a range of optics including ZR and ZR Plus optics without any restrictions. This line card can support 48 ports of 100 gig via CS connectors and 96 ports of 100 gig through 4x100 gig breakouts. Each LC9600 has 6 Trio ASIC, where each ASIC can deliver a throughput capacity of 1.6 terabit. It has a line card CPU, which performs many important functions such as JFlow, MACsec key exchanges, logging, etc. The line card has high feature scale. For example, it can support 13 million IPv4, IPv6 fib entries, more than 58 million flow records, 256K filter terms, and best load balancing algorithm. LC9600 is fully interoperable with Trio-based line cards such as LC2101 and LC480, along with all the upcoming new line cards. Third and final product that I would like to talk about is MX10004. It's a 7RU system with a depth of 1005 millimeters, along with fan tray, handles, and air filters. It has 4 input-output slots, and it's a fully redundant chassis with 1+1 RE redundancy, 5+1 fabric redundancy, 2+1 power supply redundancy, and 1+1 fan tray redundancy. It will support all the shipping line cards including LC480 and Trio 6 based LC9600. So this chassis from day one can support all the port speeds starting from 1 gig all the way up to 400 gig, along with all the advanced features and marketing use cases. With that, I would like to conclude my session. Thank you.